Alright, here is how you make equations given a parallel perpendicular line and a specific point. And you'll notice what I'm going to do is I'm going to highlight here. I've got an x value 3 and I've got a y value 7, and I'm going to plug them in for x and y here. Now the important thing, you'll notice over here I put a b instead of 5, because the rule is if the line is parallel to this specific equation, then my slopes here have to be the same. And now I've got 7 equals negative 6 because I'm multiplying negative 2 times x, and x just happens to be 3 in this scenario. And now it's a simple one-step equation to find b. Add 6 to both sides. And your final answer is 13. Now you have to recreate your equation. It's y equals negative 2x plus 13. So anytime you're looking for parallel lines, you know the slope has to be the same, so it has to be negative 2. And really you're just finding the y-intercept. Okay, next example. What if my slopes are fractions? That's okay. I know my new equation is going to be y equals 6/7 x minus 8. And again, I have to plug in my x and y. So I get 4 equals 6/7 times negative 1 plus b. And 4 equals negative 6/7 plus b. And unfortunately, we don't like fractions. They make math a lot harder, but sometimes we got to work with them. Add 6/7 to both sides. Over to the right here, I'm going to do a little fraction work. 4 over 1 plus 6 over 7. Now, when I multiply fractions, very easy. I can do anything I want. When I add or subtract, very specific. So in order for me to add or subtract a fraction, I need to have a common denominator. I need to have 7 on the bottom. And I do that on the left fraction here, 4 over 1, by multiplying the top and the bottom by 7. Now I get 28 over 7 plus 6 over 7, and I just add across the top. Now I like it when my numbers cancel out and make whole numbers, but it doesn't always work that way, so you can just leave it like this. And I write my final equation, y equals 6/7 x plus 34 over 7. And I'm done.